Hello everyone, welcome back to Dragonfly Engineering. So this week we are going to use the EDM machine to rough cut some profiles and some reference plates that will define cavity locations on our dual shot mold pair that is used for molding rubber over polypropylene and that we talked about in the previous episode. So enjoy the show. Alrighty, so we're over here on the Haas TM1 and we've already sawed up the A2 tool steel that was pre-ground. So it's 8 inches wide and it was over 4 feet long. So we've cut that into 10-inch pieces plus an extra 3/16, for the saw kerf and everything. And now what we're gonna do is set up on this mill to face both ends of the rough sawn precision ground stock to the final length, or 10 inches exactly. So we'll have 8 inches that's ground, pre-ground, by ½ an inch that's pre-ground, by 10 inches on the length that will be machined with this mill. We're gonna do a rough pass and then a finished pass. And I've got this 10-inch stock sitting in this 6-inch vise so that we can do both sides at once and then use the accuracy of the mill itself to cut in exactly the dimension that we want. So we're gonna do a rough cut and then a finish on the 0 side, and then we're gonna go over and do the same thing 10 inches over per the encoder on the mill. So I've got the program loaded. All right, so what I'm gonna do is I'm going to set the Z kind of arbitrarily, and we're gonna use the upper portion of this ½ inch 4 flute with a chip breaker end mill. That way, we can use some of the underutilized parts of the flutes. And the Y-axis is not very critical. I gave ourselves an extra kind of ½ an inch on the top and bottom. And then the X-axis isn't very critical either because this stock is oversized. So I've offset in the toolpath program. When we bump the stock up against the unfluted part of this end mill, that will set the stock. So we're actually making our vise stop be the end mill itself. So, but you got to be careful. You want to reference the non-fluted part so you don't start chipping off the edges of your flutes on your end mill. And gentle, but the precision is going to be in the DRO or the encoder of the mill. And we are just getting the stock in that envelope of 10 inches, and it doesn't have to be very precise. But you want to make sure you do it right so you don't waste a bunch of your pre-sawn stock. Okay, so I'll bring you in a little closer and then we'll do all of that. Yeah, let's go ahead and set the stock using the end mill right now. Now what I'm going to do is move the end mill this direction by ¼ of an inch, or 6.35 millimeters. And then that way we will reference the edge of our end mill. Thus, the stock will be at the 0 location in the program. So now I'll slide our stock over. I'm gonna bring the Y forward to about the middle of the stock. And I'll bring the Z down until we're starting to get into the fully developed shaft of the end mill. And then I'll push our stock over. Oh, I need to go up a little bit. I was on the tool holder. Like that. I think I'd like to center this stock a little more. So with the vise loose, I'm going to push our stock over to what looks about right. Okay. I'm going to snug down just slightly because we don't want to roll the stock and then chip our tool either. And then I'm going to pull up on Z. Then I'm going to tighten this thing. Okay, I'm going to go back to the offsets. I'm going to say this is part 0. I'm going to move over 6.35 millimeters, or ¼ of an inch, which is another way of offsetting our tool half the diameter so we can use the tool as our reference stop. Our ½ inch end mill is on the center of our stock. And then again, the program itself actually says that the real stock edge that it's going to machine to is about 2 millimeters in from what we call the center, or the rough center of the stock. I usually set the Z height with a tool offset only. So my Z coordinates in the mill, I always keep it 0. So another way of saying this is that I'm telling the mill that the height of the tool is basically almost the entire length of the Z axis itself. And it's just one less number to deal with. When you get into more complicated 5-axis machining, you have to have a Z location for your part and then tool offsets. But for simple 3-axis machining, I find it's easier just to always leave Z as 0 and deal with your tool heights only in your tool height list. Or the mill is thinking that the tool height itself is this distance from the Z0 location. It's thinking that the tool is like this height. But in reality, since my Z is 0, I'm just making things easier by dealing with it with tool offsets only. So hopefully that made sense. Then we're going to go and do our first cut. It looks like it's going to cut the opposite side first. We can speed up our feed. And we're going to climb mill all of this as opposed to conventional milling. We're going to drop into the cut. I'm going to pause it here in a second so we can get our coolant started and zoom in on the camera. And there we go. And this is A2 tool steel in the annealed state. And we got our end mill extending beyond the bottom of the stock such that we can use some fresher portions of this used end mill at the top of the flutes. Now we're going to do the finished cut on this side. So this is the Sodic Sinker EDM, and we're going to use this EDM to cut in all the little cavities for our dual shot mold that we're working on. And I am also going to use it to rough out some of the guide holes for all of the cavity inserts that we're going to burn into the plate that we just squared up on the Haas mill behind you. So for those who haven't seen some of my other episodes, I've got a few episodes where I use the Sinker EDM, sometimes called a RAM EDM. And effectively what you do with the EDM machine is you electrify this copper shape or a graphite shape. And usually you machine your features into the graphite or copper as a positive feature in the case of a mold. Then you load your pattern into the electrode spindle here, which can rotate and move X, Y, and Z. And you put your stock down here in the base, and you line up everything, and you turn on the EDM machine, and it will work its way down through the stock and erode away your stock, conductive stock, using electric sparks. You know, every time the spark hits the steel, it blows a little chunk off of the steel, and then it's flushed away with a bath of oil. So there's a reservoir that rises up out of the base of this machine, and this whole thing fills up with EDM oil, or a dielectric fluid is what it's called, which can be DI water as well, but not for this particular machine. And yeah, so its EDM processes are on the slow side, but usually you can set it and then work on something else, and basically the machine just runs by itself for most of the day. It's not advised to leave, or if you do leave, then you want to have a camera on it, because in extremely rare cases these days, the EDM oil can catch fire, and you don't want to be at home while this is machining at your shop and then the thing catches on fire. It does have a fire extinguisher system in it, so if it detects that there's heat from this detector right here, then a big old powder fire extinguisher discharges and covers everything with fire extinguishing powder and probably CO2 gas. I'm going to flip this jaw to the back side because they don't quite have 8 inches here of travel. Okay. And I'm going to tighten this first piece of stock down. We've got 4 of these to EDM out, the rough squares right here. And we can only probably do the one on this side because of the clearance issues that we would have with the fixed base of the vise on this side. Okay, we're recording.
Okay.
Do you want to get that lid off and I'll tear apart the crate?
All right. Here we go.
Is that hinged? Oh, there we go. Quality. Okay. Looks like it's stapled. I wonder if I should just try to lift it out.
Yeah, that's what I'm thinking.
Maybe you could put the lid back on the crate after I see if I can pick it up.
Okay.
Yeah, I think I can pick it up.
That's pretty. Okay.
Oh, they even have a Darth Vader mask in there. Okay, there it is.
Oh, weird.
Oh, they
There's a
gave
Darth
samples.
Vader mask in there.
They gave samples of plastic too.
Oh, that's nice
That's
of them.
nice.
Oh, here we should show the hold on, the Darth Vader mask to people.
Oh yeah, they even did a test
Oh.
profile. And then we zoom in.
Okay, so the plastic that comes with it.
Oh, nice.
Yeah.
Maybe we just bought some extra plastic on Amazon, but I'm sure it will come to good use. Here, let me zoom in on that. Here's Darth Vader as a test sample, and they actually shipped their test piece in there. You want to pull the mask out and then show the clear part?
That's kind of interesting. It's got like an eyeball.
That's neat. Cool. All right, so we're going to move this new vacuum former bought on Amazon over to a workbench, and we are going to try vacuum forming our own parts.
So we have a temperature display, probably temperature time profile. Let's probably go and stop. Emo switch, power switch.
Neat.
Yeah. And fuse back here next plug.
Oh, okay.
Pretty simple design.
I guess we could put this on the
And
table, and we can try it out, make sure it works with the Darth
With the
Vader mask that
plastic?
they provided.
Yeah.
Nice.
Oh, and this I guess the plastic that they sent is 0.5 millimeter.
Oh, okay. All right.
So this is
And
is like flexible.
And we just purchased what?
0.06 inch is what we purchased.
Oh, okay.
So they should be thick, like a little bit more rigid than this stuff.
Okay. Well, let's set up a space on a table next door, plug this thing in, and play with it.
Sounds good.
All right, so here are our rough cut EDM plates, which will go on the fronts of all four surfaces of the molds. Like, actually it goes like this. So anyway, I already knocked out the two inserts on this one. There's a couple of rough areas, but not too bad. And then this is the stock we cut out, and you can see that kind of that EDM, that very rough EDM spark erosion finish. Yeah, so anyway, that's the roughest setting for just hogging out shapes or just making the quick cuts to cut out these blocks of A2 tool steel out of our 1/2 inch plates. And now I can use these inserts, or these, not inserts, but these drops for additional mold cavities in the future for different projects. And so this is about, how much material was actually removed, just these black lines. It's approximately 1.5 millimeters or 1/16 of an inch. And that's the back. Now, some of the corners didn't actually connect and burn all the way through. which is okay because we're just rough hogging these, and I'll bet I can just whack this guy out with a hammer. So that's actually this one I can just remove by wobbling it back and forth and just kind of breaking the tabs that are remaining for these parts or for these drops. Yeah, so pull that guy out, and this one I may have to tap with a hammer. Here we go. And then you can see the EDM finish in there again. So the next step is going to be with an end mill, I'm going to face mill the whole side of this, which basically improves the life of an end mill when you're cutting into tool steel. So the end mill is going to drop down and then go around and machine this pocket out to the actual final shape. This extra burnout here is okay because I've got little mouse ears or dog bone shapes, which allow for the radius of the tool to create a sharp corner here. And then what we're going to do after we machine all the reference features and dowel pin holes and mounting holes and everything into this plate, we are going to load it onto the face of our mold surface and then populate this plate with all of our multiple cavities, which I'll grab those right now. All right, so I got some footage of machining these steel mold inserts, and effectively once we machine this shape to our final size, these precision blocks with a profile of the part on the A side of the mold will fit right in. So the idea is that if we roughed out with the EDM machine correctly, then when I lay all these blocks on our rough hole, then I shouldn't see any of the roughed out parts poking through, because we want to do the precision machining with the CNC for these holes. And it looks like we are going to be okay. And then the rest of them go down here. I still got a few over there on the bench. And these basically just machined on the Herco mill this week. And it's just a matter of squaring up the rough stock. And then here's some of the rough stock for the B-side inserts, which mostly will be EDM cut, but you can see how we got them ready to go. And those will basically fit into the other side of the two molds just like we're doing here. Once we machine the precision pocket for all these squares to key in, almost like stacking dominoes in here. And then 2 screw holes will hold these down onto the aluminum subplate right here. So that's the idea. And that's the shape. You can see the degradation of the end mill as we were machining these duplicate blocks. So like some of the earlier cuts look a little nicer, but then some of the later cuts before the end mill was changed, the 3/8 roughing, or not a roughing, but a 3/8 4 flute steel cutting end mill. You can see that the surface is a little more kind of muted and brillowed as opposed to a nice shiny fresh cutter from part 1. On one part, the first part versus the last part before I switched out the end mill. Hi everyone, well I think that'll wrap it up for this week. If you'd like to see more of Dragonfly Engineering, please like and subscribe and hit the bell icon for seeing more of these episodes in the coming weeks. And we also will continue with machining the base plates that will, for the 2 molds, which are aluminum mold bases, to receive all of the mold inserts and the reference plates that we worked on this week. And if possible, we will get going on the B side with all of those inserts with the EDM process, where we're going to machine graphite and copper electrodes and then do more of the fine precision EDM work in subsequent episodes following this week and next week. So thanks for watching, and I'll see you guys later. Bye.